that at least when you get to understand that a bit better, and then you can ask me as we go along around things in chapter 8. So by all means, I think this is now a nice opportunity for you as well to get the things sorted out in that chapter. Okay, so what I just highlighted with the things that we will be going through. I think what is important nearly is how they call certain things. So arithmetic mean is just a normal mean. It's just an average. Um, so that one can work out in Excel. One can work that out with your calculator. A weighted mean, they need to give you weights to work that out. And that example that you said me is actually a perfect one around weighted means. So we'll definitely work that out. Standard deviation and variance, you again will need to use or your calculator or Excel. So we'll look at that, and then we get into linear functions. On the linear function that you will have a slope, on the linear function that you will have intercept. With the linear function, you can look at correlation or regression. You can also use a scatter diagram to draw a linear function within it to see how the correlation is with the data. And then there's two other things that from a linear function one can also work out is correlation of coefficient and the coefficient of determination. So it's basically just a r over r squared that we're talking the last two. But we'll touch on each one of those in the next hour or so. Okay, so it's always interesting. They make it sound very difficult, but a simple summation is basically you sum everything. So if they gave you and let's go to Excel nearly. So if they gave you, where is my zoom so that we can just make it bigger? So if I gave you the numbers 5, 10, 30, and 60, and maybe in this course we will rather use rands or whatever, but if you need to do the sum of that, it's as simple as the sum of those functions. You will even see that in here is that summation of an autosum. So it could even in Excel it can be added automatically, but that is basically what it means. It is just the sum of a number of values. So whenever they talk about the summation of something, it is just the sum of. So it can be the sum of all the x's, it can be the sum of all the rands. So it all depends on what they nearly refer to. So, and please ask if there's anything that one needs to explain further. Then, when we look at the data component, or let's first, on specification, sometimes they have all these weird subscripts. Um, so sometimes they have something like J or I to the number N, and they do something like that. So all that means is you start at your first X, because your first X will be X1 up until all the way up until Xn. So that is just what that summation actually does. So in the Excel, we would have had X1, X2, X3, X4. So our thing would have looked like is J equal to 1, Xj, and we would have said N equal to 4. So that is basically what it means. So again, I don't think they will go into much of that detail nearly. I think they would ask more something on population and sample, or what's the difference between the two. So if they ask something around it, but population is just looking at the bigger group, where the sample is taking a portion of that bigger group. So we can say the population of South Africa, and that is what we then say is the population, and the sample of that could be the population of the Western Cape. Or we could say it is everybody that has a length higher or height higher than 1.8 or something like that. So the sample is just a subset of the population. So if they are something around sample and population, it will be more around the definitions. But again, you guys must be writing open book, because it is an online exam. So I assume it is open book. So I don't
I haven't
think.
heard anything about whether it's open or closed book. I seem to recall that they've always been closed book, but I don't know what's happening now.
Yeah, it used to be closed book, so that is one wondering how can they use all the invigilator apps and stuff, but that nearly picks up more people than it will pick up books, or because you can also just write in a book, so it's not so it's. So I wonder how that will be. But okay, if they ask you something about it will most likely be a definition kind between population and sample. Then in the arithmetic mean or average, so I thought, okay, but let's look at example, or what is it, exercise 8.1, and we can, what I thought was, we can just put in the data. If you're allowed to use Excel, you can just use this spreadsheet later on as well. I will send it to the WhatsApp group as well. I just think I need to add it to the other sheets, that you only need to work with one. So, but if you get a set of data, like in exercise 1, what I now want to do with this is nearly to show all the formulas that are available for you, so that we can, in certain instances, make it a bit simpler, because what we will look at is your mean. We will look at standard deviations. We look at variances. I think that is nearly it in this. So let me I'll just call it mean. So if we look at it in this one, if we want to work out the mean, it's also called the average. So we can just use this whole set of data and work out the average. What you could have also have done is to say, well, they taught us the summation. So if we sum everything and we divide it by how many numbers there are, we're supposed to get the same answer. Okay, so there you can also see, dependent on, doesn't matter if we used the Excel formula or the one where we had the summation divided by how big n is, we will get the same answer. It's in your exam, normally if you're not able to use Excel, they will not give you this big data set. So they will then give you a data set of nearly 4 or 5 variables. It will never be around 30 or 50 in some of the other examples and things like that. So it will always be a much smaller contained set, nearly, so that it's easier for you to work out the numbers. So they will never give you this big data set and then ask you to work out the standard deviation unless you're allowed to use Excel. So if we needed to work out standard deviation, there's also a function for that. And remember, we're working with a sample, so we use the standard deviation of a sample. I will also now show you something else as well. We also can work out the variance, but again, variance of a sample. So again, we will take that. The other thing that is important is nearly your standard deviation is the square root of your variance. So if you set squared that number, you should also get the same answer. So there is a few things that we can nearly test if we are on the right path or not. Sorry, I just needed to let the cat out of the room. So yeah, so this is, if you sitting with a lot of data, this is how you would do it in Excel. If you So let's just say just a lot of data, so that the next one I want also to show you. Okay, so if we only had the small set of data, so let's say that was our x variables or our x numbers. If we only had that and we needed to work out the standard deviation and all of those things, we can still use Excel in a different way, because we still need to work out the average. So in that formula, where is that formula on page 144? So what I'm just going to do is I'm going to put that formula for you in a spreadsheet nearly. So again, that if you have something like that in the exam and you can use your Excel, then I think it's also easier. So when you look at how you would have calculated your variance, the formula for your variance is your x value minus your mean and then the next part of that is that we need to make it to the power of 2. So you will see how that is on the top of that formula. But we need to do it for all the x's. So we need to do it for basically all the x square unit or x minus the mean. You need to square it for all of them. So then with that, you would have gotten, again, like I show on page 144, you need to take the sum of that divided by how many there are. So I'm just going to say divided by count, because then it's okay. So my variance, and we're going to test it now as well. The variance is 31,36, and my standard deviation then is basically square root of that. Okay, we just need to make one adjustment. It is n minus 1 because we're working with a sample. Okay, so that is, if I were using that formula on page 144, I would have said x minus the mean. I will get that to the power of 2. I will get that. I need to do it for all 5 of them. Then I need to basically sum it. That will give me the variance if I sum it divided by n minus 1. Standard deviation is just the square root of that. But to test it, it should also be exactly the same. Thank goodness it is. And the standard deviation of a sample should also then be exactly the same. So at least both methods that that we looked at is working. So what can happen is that in the exam, they can ask you on this piece of the smaller set of data to work out variance or standard deviation, where you need to show it with a formula. But again, to show it with a formula, you're just going to pick an answer. So it doesn't matter which method you use as long as you get to the same answer. Does that help a bit?
A bit.
Okay.
That question that I sent you, what puzzled me was, do I have to add up all three columns?
No. Okay, so that we will do now. Okay, so and this is what is tricky about this one is, so they give you the three columns, but they ask you a weighted average interest rate on the amounts invested. Okay, so the amount invested. So what you will do is, so what you need to do is you need to nearly work out a weighted average. So if you look at where was that weighted average formula, which was also a bit confusing if you look at it. So on page 142, I hope my reference of a study guide is the same as yours, where they talk about weighted mean and they give you their formula. So they told you in this one, you need to work with the amount. So weighted interest rate with the amount. So you basically will do an amount times interest rate. So that is also what they in that formula on page 142 nearly say, that you need to multiply those two, but you do it for all of them. And then what you do is you basically now need to work out the weight of that. So you would say that the sum of all of these divided by the sum of the amounts, because they said in the question, they said to you the weighted average interest on the amounts invested equals. So you will nearly then need to multiply each one out like we did in here. So you multiply those two out, you do it with all of them. You get us, and let's just call it totals. So you get a total of the amount. You get a total of the amount times the interest rate. And then to work out the average weighted, it is that interest rate one divided by that. And you then just need to put it in a percentage. Okay, but what is tricky with this one is also that, so for the one that I think that was marked, so that would have been, oh no, there wasn't. So how did you, or was it somebody else that marked it as the
No, it was
33.57?
somebody else that it came like that from the place where I copied it from.
Okay, cool. So because what I also looked at, so if you just set the average of all of those, then your option would have been option 1.
Okay.
So there is also that option 1 that is available, which obviously is wrong because they ask you to look at the amount. The other thing that I also, so if you did it on the number, okay, at least not the same. So at least it's not. But again, nearly to look at what we need to do. So we say that amount we need to multiply by the interest rate weight, basically, and we need to do that for all of them. So that is what we need to do.
Okay, I've got it.
Okay, cool. So yeah, I thought it. I first looked at it and I'm like, this is, and what question was it? So, okay, so at least it was the last part of the question set. So you would have assumed it is part of the last chapter, but sometimes they also not as 100% aligned to what you need to do.
Yeah.
Okay. But I will also, let's just, add that in there. I think I did. Okay, so there it was as well, but let me just delete that. So it's basically, and what we can add to that is the sum of. Okay. Okay, so that covers that question. Again, as you're prepping for the exam, just send me more and we will work through it in the last 2 sessions or the next 2 sessions that we will have.
Okay.
No problem at all. So we've looked at the standard deviation and variance, and again, I think that is, you will not get anything different to nearly what is in here. So if you have lots of data, use you you can actually only use Excel nearly, because you're not going to do this method work out by hand for 20 or 30 X values. That is just not going to happen, and they will not expect you to do that. If they want you to show this calculation, so what they can maybe ask you is, what is the sum of square or something like that, so that you, on that formula of page 144. So let me, as we just now look at it, so they can maybe ask you to, if it is a smaller set of data, to tell them what this amount is. That they might have as an option, so that you know that you can actually get that by just doing the sum. So let's, for that instance, let's just add it so that you have it the sum of squares. So that can be some of the things that they ask you to say what is the sum of squares, and they can give you a few values. But else, again, it will not be on a big data set, because again, it doesn't make sense, because it will take you quite some time to do that. Okay, so then we go into this describing relationships, so with linear functions. So at this stage, we in maths or somewhere, would have seen this mx plus c, that you use for a line. So okay, so it is still doing that. So what we would get on a, if we have an axis, you have your x and y, and this line will say go somewhere through there. It can be anywhere, but that cutoff at through the y-intercept will be c. So if this formula was, say, 4x plus 3, we know that that would have been actually then equal to 3. So your straight line basically would give you details of where it cuts through the y-axis, where it cuts through the x, if it is positive, if it is negative. But we will quickly look at an example to make sure that we just get that right. So basically x-y axis, so that you only need to worry about straight lines. So there is not any cube or quadratic or any functions like that in 1630. So it is only looking at the straight line. So it is only looking at the regression line. How we work out the intercepts of that. So let's say that was the formula. Let me just quickly write down. Okay, so let's say we had the straight line was 5x plus 20. Okay, so that is our straight line. We need to nearly show how it would look on the graph, or on a graphical representation of that. Okay, so if I look at my this is the C, so that is the Y cutoff. So somewhere here is my Y cutoff. Sure, now this is giving lots of issues. Don't know why it is doing this. Okay, so that is supposed to be 20. But I don't know where on the x-axis it is the cutoff, but I know that x-axis goes through the point where y is equal to 0. So I can replace in my straight line, I can say, okay, where y is equal to 0, it must be 5x plus 20. So where y is equal to 0, 5x will be equal to minus 20. So still where y is equal to 0, my x will be equal to minus 4. So actually, here at minus 4, the line would go through and then through the 20. Okay, so that would have been how you can get the two intercepts of this formula. Okay, then another point that they would look at is to say, but determine the slope of this line. So we know the slope is what is in front of the x, so it is 5, but let me show you from these two data points how we could have done it as well. On page 150, they tell you that how to work out the slope is it's the difference in y divided by the difference in x. Okay, so we need to get 2 points on this line. So here we've got a point of minus 4, which is x and y 0. Here we've got a point where x is actually 0 and y is 20. Okay, so we've got 2 points that we can work with. So the difference in y, so we say 20 minus 0. The difference in x, so we say 0 minus 4. So we have 20 over 4, which would give us the 5. So which gives us that 5. So that is also a way that we can work out that 5 is by the change in two numbers. Okay.
Okay.
Does this make sense?
I must just tell you,
Yes.
I never did maths at school.
Okay. so yeah, so it is a big refresher on this then.
Yeah.
Okay, but I think as you see examples of this, try it. Else also nearly WhatsApp me and say, but please help me, or because
Okay.
normally it is just one or two things that nearly needs to click, and then it is easy because it's the same process every time.
Okay.
So with the straight lines, nearly it's the same thing that you do every time. How to do it. Okay, so that is nearly the straight line and the slope. And we had also looked at the 2 points. So we nearly covered that all in in this, what they also can do is to say, let's just quickly take this away again. So the other thing that they can do is to say, but instead of giving you the straight line, I can just say, okay, here's 2 points. And the straight line that you need to get to is going through these 2 points. So then we can again look at it to say, okay, let's just, I hope it's something realistic that I know. So let's say that is your point 2 and 3. So that was 3, 4, 5. Okay, so let's say that is your point 5 and 4. So it does seem at least something that can work. Okay, so it's something like that. We know that point. We know that point. We don't know where it is going through. But what we know is this is my normal formula. I know now, because I've got 2 points, that I can work out what my slope is. So my slope is the change in y over the change in x. So the change in y is that 4 minus the 3. And the change in x is that 5 minus the 2. Okay, so this is not too cool, but it is 1 over 3. So at least I know that my m is now a third. So then what I can do is, I know that this line, this point or this point actually lies on that line. So I can replace into this, and let's say I replace into here the 0.5 and 4. So I know then that this is x and y, so y, the 4, is equal to a third times 5, because that's my x value, plus c. And so again, this is not going to be that great. 5 over 3 plus c. So I need to take it to this side. 4 minus 5 over 3. Oof. And so that is 1. So the answer would be 2 and a third. Okay, so C is 2 and 1/3. So then I actually have my whole formula of y is equal to 1 over 3x plus 2 and a third. Okay, so by just looking at 2 points, we could have done or worked out a line as well. And this would be now 2 and a third, which is a weird number, but it's because I just picked random numbers. Okay, normally it will be if you need to do something in the exam, it will not be strange numbers like that. It will be full numbers, a 3 or 4, 5 or something like that. It will not be thirds or anything like that when you need to do the straight lines. Okay, that's nearly another way one can look at it when you only have two points.
Okay.
Okay, so that's just nearly want to make sure that we've covered that. Then the other part here is it's about correlations and regression analysis. So again, if you look at, there is really if I look at if you look at the formula on page 159, the Pearson's correlation coefficient, I really hope, and it would be actually nice to see what they ask you guys on this in your assignments, if I gave you data or what they actually did, because again, if we look at something like example 8.10, I would do that again in Excel. So the other thing, you can also do it in one of your financial calculators where you have the X and Y that you can put in as a data point. So, but then if you can use your financial calculator, it's also fine actually to use Excel, because it both going to do the same thing for you. Okay, so when I look at example 8.10, I need to look at the data points. So I first put in all those, the X values. I will put in the Y values after that, but just checking the power is off, so it's very dark to see all these small numbers. So if you had a HP calculator or Sharp or whatever, you normally would be able to put in a X and Y data point. And you would normally say X is the first point, then Y is the second, and you will continue until you've added all of them. Which in this instance you can also do. So then the things that we normally would then have in those formulas is the sum of. So if you look at that Pearson's coefficient, they would sometimes say, okay, but what is the sum of these things? You can do it for Y as well. Other things that they will ask you to do is to say, but what's the average? And now I must not include the sum as well. So the average I can get, you can get a lot of other functions as well. But for me, what I would just do is there is a correlation formula. And in this correlation formula, all that you need to do is put in the x's and put in the y's, and that will work out your, what did I not do? Okay, that's for one array. That's the other one. Okay, and that would be your correlation coefficient. So again, much simpler in Excel. You will get exactly the same answer if you use your, well, I've got the HB, so if I use my HB, I get exactly the same answer. And then remember the correlation coefficient is what we call R. Okay, not that R. So let's just then make it capital letter that it doesn't. But then if you need to work out your coefficient of determination, that is just your R square, which basically means that to the power of 2, which will then give you the 0.70. So you could, let's see if that was actually the same numbers. So they're not getting the same numbers. So let's just see if my data was the same. 10, 5, 14, 8, 13, 6, 15, 7, 18, 10, 15, 6, 20, 10, 21, 12, 23, 8, 25, 13. Oh, okay, no. So they got 0.8007, which we also got. And then when you do the coefficient of determination, I just rounded it off to too many, then you get the 0.7068. Again, depending on, normally they want this one in a percentage, when you just say it is in a percentage form, and then when you normally want it as just 2 decimals. So let's just do that and then say percentage as 2 decimals. Okay. So again, it's, if you do it on your calculator, you will get exactly the same. Your calculator, or well, my calculator also doesn't have a coefficient of determination. I still need to work it out, so I still need to multiply it. And I think most of the calculators, you actually still need to work that out, but that is basically to say the same as that times itself. Okay, so it is exactly the same to say that value times itself. Okay, so that is nearly it for this chapter 8. Does it help a bit?
No, that does help.
Okay.
Mm.
Okay, so yeah, I thought, yes, there is all the formulas as well. So that's why I nearly want to see what, if if you have an example of one, or it should have been in your last assignment, I assume, but I assume also all the assignments was online, so you don't really get anything
I'll look
as,
on the where they gave us the answers.
okay, because With your assignments, you were allowed to use Excel or the financial calculator. Or
I don't know. All I know is that they were told they could use an online calculator.
okay, but that's also that's even easier because then some of these online calculators can
They
do
work it out
exactly.
for you.
Okay, so yeah, because some of those online calculators can do exactly the same, so
Mm.
and even better. So okay, but yeah, then to use Excel would not have been an issue at all if you were allowed to use an online calculator.
Yeah.
Okay, is there anything else um on this that you want to look at, Caroline, or do you first want to let everything sink in?
I think it's going to take a lot of sinking in, but this I'm quite happy with. This one is no problem
Okay.
because
Okay.
this one I can work out quite easily on the calculator.
See, and that's why I think this one, so if it is just to do with the regression line and you need to do the coefficient and those things, calculator is very simple.
Mm.
It's more these weighted stuff and the standard deviations and those kind of things that are a bit more difficult because it's not as simple on a calculator to do that. But yeah, please, if you see more of this type of question, I will also now go through some of the old exam papers that I have and just check specifically for these things. It's interesting when I now looked at it, it's strange in all the years that I've been assisting with DSC with the 1630, we nearly never had enough time to get to study Unit 8. So I never had any notes on it. So this was now the first time. So it was always a rush to get to it. So I will specifically look at a few of my old exam papers that I have and just check on these things, what there is, and because I've normally what they do is they ask you one of these, but when they ask one of these strange ones that one or two of the strange ones, and one wants to get that right as well because it is a lot of points for one
Yeah.
question. So yeah, okay, cool. But then yeah, I think that's it for tonight. That will be if it's okay with you.
That's fine with me.
And
I can go
then
with my exam papers and go and find them.
yes, so and I think that is so. If nobody else says anything on the chat, we basically will make sure that when you are sorted with questions, that for me is I don't mind doing that at all. So look at previous exam papers. I will for the next two sessions. We'll look at an old paper so that we at least cover everything in the last two sessions.
Okay.
But please send me things that you come across. Really have no issue that we add that into the discussion of the last two sessions.
Okay.
Cool.
Okay.
When when are you writing your first exam?
I'm actually doing a portfolio at the moment, which is my final for CAS 1501
Sure. Okay. When does that need to be in?
by the 23rd.
Okay. Good luck.
Thank
Okay.
you.
Yeah, so focus on that now.
Well, what I'm trying to do is I'm splitting it because I'm like doing 5 questions a day on
Okay.
that, and then going over to the maths as well.
Okay. Yeah. Good luck. That is that. That is quite. Let me stop the recording. That we don't need to.